Hello everyone, welcome back to my channel. Today I'm going to be doing a quick lecture about heterolytic bond cleavage. So let me title this lecture Heterolytic bond cleavage. Heterolytic bond cleavage is also sometimes called heterolysis. So I'll put that here in parentheses. So heterolytic bond cleavage is, as the name implies, a type of bond cleavage. So we're having a bond breaking. And if I were to give you an example of this, we might have a neutral species, X and Y, and using heat, we have the movement of two electrons to one atom, and this forms a positively charged species plus a negatively charged species here. And these are done under heated conditions. So in a heterolytic bond cleavage, we have a bond breaking, and that forms charged species. And these charged species are called ions. Here, this negatively charged species is called an anion. And an anion is just a negatively charged molecule. We also have a positively charged species being formed here, and that is called a cation. And a cation is just a positively charged species. Another important thing to note here is that we're using a double barbed arrow. So we have a double barbed arrow here. And the double barbed arrow is just symbolizing the movement of two bonding electrons to form the anion and the cation, respectively. So heterolytic bond cleavage results in the formation of charged species, and it typically occurs in polar covalent bonds. When I say polar covalent bonds, I mean that the two atoms that are bonded together have a very, very different electronegativity. So one atom will have a higher electronegativity and the other atom will have a lower electronegativity. So in a polar covalent bond, there's a difference in electronegativity. Generally, the more electronegative atom will attract electrons to form an anion. And the less electronegative atom will form the cation. So let's just take a look at a few examples of heterolytic bond cleavage. We might have a neutral species such as this. And in the presence of heat, this atom, bromine, is very, very electronegative compared to the carbon. So what might happen is carbon transfers its electrons to bromine, and we have the formation of a positively charged species here, which we call the cation, plus the formation of a negatively charged species here, which we call the anion. Let's look at one final example. We might have a neutral species such as this, and in the presence of heat, we have a difference in electronegativity here. This should be a hydrogen atom, but we will have a difference in electronegativity here, where the chlorine atom is more electronegative than the carbon. So carbon will transfer both of its 2 electrons to chlorine, and this forms positively charged species, which we call a cation. And we will also form a negatively charged species here, which we call an anion. So to summarize really quickly, heterolytic bond cleavage is the breaking of bonds, particularly polar covalent bonds. And these polar covalent bonds will break due to a difference in electronegativity, where the more electronegative atom will form a negatively charged species called an anion, and the less electronegative atom will form a positively charged species called a cation. But that's it for the lecture today on heterolytic bond cleavage. If you like this video, be sure to comment, like, and subscribe, and also keep in touch on my Instagram, Pinterest, and Medium that are linked in the bio below. But that's it for now, and I'll see you in the next video.